In 1970, a farmer in rural Iowa could walk into his barn, reach into a burlap sack, and pull out seeds his family had been saving for 6 generations. Those seeds had survived droughts, floods, blight, and 2 world wars. They had fed his grandparents through the Depression without a single dollar spent at a store. By 1985, that same farmer could be sued for doing the exact same thing. Not because the seeds were dangerous, not because they carried disease, not because they failed to produce. He could be sued because a corporation had figured out how to patent life itself, and the legal framework of the United States bent to accommodate them. The seeds your great-grandparents saved, traded, and planted freely for centuries became the intellectual property of a chemical company based in St. Louis, Missouri. And the crop varieties they replaced were not inferior. They were, by almost every measure that matters to a person who actually eats food and works the land, superior. So why were they erased? Why did an entire generation of farmers abandon seed lines that had been refined over thousands of years in favor of patented hybrids and genetically modified organisms that required annual repurchase, chemical inputs, and corporate permission to grow? The answer is not complicated. It is just ugly. And it has cost your family more money than you realize. By the time you finish watching this, you will never look at a seed catalog the same way again. You will understand what was taken from you, who took it, and exactly how to start taking it back, using nothing more than the soil you already have and knowledge that predates every corporation on Earth. The story begins long before Monsanto, long before the USDA existed, long before anyone imagined you could own a plant. For at least 8,000 years, human civilizations practiced a form of agriculture that modern agribusiness would rather you never learned about. The Aztecs cultivated amaranth as a primary food source, a grain so nutritionally dense that the Spanish conquistadors banned its cultivation in the 16th century. That is not folklore. That is documented colonial policy. Hernán Cortés understood something that industrial agriculture spent the next 5 centuries trying to make you forget. The most dangerous thing a population can possess is a food source it controls completely. Amaranth did not need irrigation infrastructure controlled by a ruling class. It did not need fertilizer imported from distant mines. It grew in poor soil. It grew in drought. It produced edible leaves within weeks and grain within months, and a single plant could drop over 100,000 seeds. The Aztecs mixed it with honey and shaped it into figures for religious ceremonies. And when Cortés saw how central this crop was to the social and spiritual fabric of an entire civilization, he did not just discourage its use, he made it punishable by death. Anyone caught growing amaranth could have their hands cut off. That was the first recorded act of seed suppression on this continent. It was not the last. In colonial America, farmers saved seeds as a matter of survival and common sense. Thomas Jefferson exchanged seed varieties with farmers across the Atlantic, documenting performance characteristics the way a modern scientist would document laboratory results. Cherokee communities maintained complex polyculture systems where specific bean varieties fixed nitrogen for companion-planted corn, while squash shaded the soil to retain moisture. These were not primitive methods. They were engineering solutions developed over millennia through direct observation and generational refinement. The Three Sisters planting method achieved something that modern monoculture still cannot: a self-sustaining growing system that improved soil fertility with every season rather than depleting it. By the mid-19th century, American farming was a decentralized network of regional seed savers. Every county had varieties adapted to its specific microclimate, its soil composition, its pest pressure. A tomato grown in the Shenandoah Valley was genetically distinct from a tomato grown in the Ozarks, and both were better suited to their environments than anything a laboratory could produce. Then came the 20th century, and everything changed. The Plant Patent Act of 1930 was the first crack in the wall. It allowed asexually reproduced plants to be patented. The scope was narrow at first, mostly ornamental flowers and fruit trees. But the legal principle was established. A living organism could be owned. In 1970, the Plant Variety Protection Act extended patent-like protections to sexually reproduced plants, meaning seed crops. For the first time in human history, a farmer could be legally prohibited from saving the seeds of a crop he had grown on his own land with his own labor. The biotech industry seized this framework in the 1980s and 1990s, Monsanto, founded in 1901 as a chemical company producing saccharin, had spent decades manufacturing industrial chemicals, including Agent Orange during the Vietnam War. By the 1980s, they pivoted to agricultural biotechnology. In 1996, they introduced Roundup-ready soybeans, genetically engineered to survive applications of their proprietary herbicide glyphosate. The business model was elegant in its ruthlessness. Sell the farmer seeds that depend on your chemical. Patent the seeds so the farmer must buy new ones every year. Then make it illegal for him to do what his family had done for generations. By 2005, Monsanto had filed over 150 lawsuits against American farmers for the crime of seed saving, collecting over $23 million in judgments. Some of these farmers had not even planted Monsanto seeds intentionally. Wind and pollination carried patented genetic material onto their land, and Monsanto sued them anyway. The knowledge of what to grow instead, the open pollinated heirloom varieties that needed no corporation's permission to reproduce, was not outlawed directly. It was simply made invisible. It was removed from extension service recommendations. It disappeared from university agricultural curricula. It became economically non-viable as subsidies flowed exclusively to commodity crops grown from patented seed. The burial was not dramatic, it was bureaucratic, and it was devastatingly effective. Now let me explain why the seeds your great-grandparents saved were not just culturally important, but biologically superior for the purpose of feeding a family from a small piece of land. The distinction that matters here is between open pollinated varieties and modern hybrid or genetically modified varieties. An open pollinated plant breeds true. That means if you save the seed and plant it next year, you get the same plant with the same characteristics. Over time, if you save seed from your best performing plants, the variety adapts to your specific soil, your rainfall patterns, your microclimate. After 5 to 10 generations of careful selection, you essentially have a custom crop engineered by nature for your exact conditions. No laboratory can replicate this process because no laboratory can account for the thousands of variables present in your particular plot of soil. Modern hybrids work on a different principle. They cross 2 inbred parent lines to produce vigorous first-generation offspring. The yields in that first generation can be impressive, but save the seed and the second generation falls apart. Yields drop by 30 to 50%. Traits become unpredictable. The plant no longer breeds true. This is not a flaw. It is the entire point. The hybrid system guarantees that you must return to the seed company every single year. Think of it like a battery that cannot be recharged. It works once, powerfully, and then you must buy another one. The nutritional differences are equally significant and equally suppressed. A study published by the University of Texas at Austin in 2004, led by biochemist Donald Davis, examined USDA nutrient data for 43 garden crops between 1950 and 1999. The findings were stark. Across those 5 decades, the average vegetable lost 6% of its protein, 16% of its calcium, 9% of its phosphorus, and 15% of its iron. Riboflavin declined by 38%. The decline correlated directly with the replacement of traditional open-pollinated varieties with high-yield hybrids bred for size, uniformity, and shelf life, rather than nutrient density. Your grandmother's tomato was not just tastier than the one you buy at the supermarket today. It contained measurably more of the vitamins and minerals your body needs. The trade was simple. The industry got higher tonnage per acre, and you got food with less actual nutrition per bite. You now need to eat more food to get the same nourishment your grandparents got from less. That is not a theory. That is USDA data published in a peer-reviewed journal and almost never discussed in mainstream agricultural education. Consider amaranth again, the crop the conquistadors tried to eradicate. Amaranth grain contains between 13 and 14% protein by weight. Compare that to wheat at roughly 11% or corn at about 9%. But protein content alone does not tell the story. Amaranth protein contains lysine at a concentration of about 5.2 grams per 100 grams of protein. Wheat contains only 2.6 grams of lysine per 100 grams. Lysine is the amino acid most commonly deficient in grain-based diets. It is essential for calcium absorption, immune function, and tissue repair. A single crop of amaranth provides nearly twice the lysine density of wheat in a plant that grows faster. tolerates poorer soil, uses less water, and cannot be patented because it is an ancient open-pollinated species. Your great-grandparents did not need a biochemistry degree to know this. They knew it because their bodies told them, because their children grew strong, because the crop performed year after year without purchased inputs. So, follow the money. Who profits when farmers cannot save seed? The global commercial seed market was valued at approximately $63 billion in 2022. In 1970, before the Plant Variety Protection Act, the commercial seed market barely existed for most field and garden crops. Farmers saved seed, neighbors traded seed, county fairs judged seed quality. The entire economy of seed was local, decentralized, and free. Today, 4 corporations control over 60% of the global proprietary seed market. Bayer, which acquired Monsanto in 2018 for $63 billion, is the largest. They sell seeds and the chemicals those seeds are engineered to require. The American farmer's average annual expenditure on seed rose from approximately $8 per acre in 1990 to over $60 per acre by 2020 for commodity corn. Across a 500-acre operation, that is $30,000 a year in seed costs alone. Add the required herbicides and pesticides, and input costs exceed $200 per acre. Your great-grandparents' input cost for saved seed was zero. For fertility, they used compost, manure, and nitrogen-fixing cover crops that also cost nothing. The entire input economy of industrial agriculture is built on the absence of the knowledge they possessed. Now, look at the grocery store. Americans spend over $800 billion annually on food. The average American household spends roughly 6% of its income on groceries, which sounds low until you realize that food prices have increased by over 25% since 2020 alone. Meanwhile, the nutrient density of that food has declined steadily for decades, which means you are paying more for less nourishment. If a family of 4 grew even 30% of its own vegetables using open-pollinated seed saved from year to year, the annual savings on produce alone would range from $1,200 to $2,000, depending on the region and growing season. That is not a projection from a homesteading magazine. That is arithmetic based on average grocery prices and average garden yields published by the National Gardening Association. The seed to do this costs almost nothing after the first year because you save it yourself. The fertility costs nothing if you compost. The pest management costs nothing if you practice polyculture and companion planting as your ancestors did. Every dollar you spend on hybrid seed, synthetic fertilizer, and chemical pest control is a dollar that flows from your household to an industry that exists only because the old knowledge was suppressed. But the knowledge was not lost everywhere. It survived in the places that industrial agriculture could not reach or chose to ignore. The Amish communities of Lancaster County, Pennsylvania have maintained open-pollinated seed lines for over 2 centuries. They grow varieties of corn, beans, squash, and small grains that have been continuously adapted to their specific soils and climate for generations. Their average input cost per acre is a fraction of what conventional farmers spend, and their soil organic matter levels typically run between 4 and 7% compared to the 2% or less found in most industrially farmed Midwestern fields. Higher organic matter means better water retention, greater microbial diversity, and more nutrient availability. It means the soil is alive. Amish farms that have been worked continuously for 200 years are more productive per unit of input than they were a century ago. Industrial farms that have been worked for 50 years frequently require increasing chemical inputs to maintain the same yields because the soil biology has been destroyed. In Oaxaca, Mexico, indigenous farmers still grow over 60 distinct varieties of corn, each adapted to a specific altitude, rainfall pattern, and culinary purpose. These are the direct descendants of the original maize cultivated by Mesoamerican peoples over 7,000 years ago. When the Mexican government attempted to introduce genetically modified corn in the early 2000s, these communities resisted. Not because of ideology, but because they understood something practical. Their locally adapted varieties outperformed imported seed in their specific conditions without purchased inputs. Studies conducted by the University of California found that traditional milpa farming systems in Oaxaca, which interplant corn with beans and squash, produced 1.73 times more total food per acre than corn monoculture when all three crops were measured together. The diversity was not a limitation. It was the source of the productivity. In the mountains of Ethiopia, farmers maintain the greatest genetic diversity of barley on Earth. Over 5,000 distinct barley varieties are still cultivated, many resistant to diseases that devastate commercial barley worldwide. When stem rust threatened global barley production in the 1970s, plant breeders came to Ethiopia looking for resistant genes. They found them in the fields of subsistence farmers who had never heard of Monsanto and never needed to. Those farmers' seed-saving practices had preserved genetic diversity that no corporate breeding program could replicate. The resistant gene was taken, incorporated into commercial varieties, and sold back to the world at a profit. The Ethiopian farmers received nothing. Their knowledge, their centuries of careful selection, was extracted like a mineral resource. Now, here is what you can do, starting this season, on whatever land you have. The first thing you need is open pollinated seed, sometimes called heirloom seed, though the terms are not perfectly synonymous. Open pollinated means the seed breeds true. You can save it. Every year it will adapt more precisely to your conditions. Sources for open pollinated seed include the Seed Savers Exchange in Decorah, Iowa, which maintains over 20,000 varieties in its collection, and dozens of small independent seed companies that specialize in non-hybrid, non-GMO varieties. A packet of open pollinated tomato seed costs between $3 and $4. That one packet, if you save seed properly, will never need to be purchased again. Start with 4 crops that form a complete nutritional foundation and are easy to save seed from. Amaranth for grain and greens. Dry beans, any heirloom variety suited to your zone. A paste tomato like Roma or San Marzano for preserving. And a winter squash like butternut or Hubbard for calorie-dense storage food. Plant the amaranth in full sun after your last frost date. Scatter the tiny seeds on the surface of prepared soil and press them in with the flat of your hand. Do not bury them. They need light to germinate. Within 4 days, you will see fine red or green sprouts emerging. Thin them to about 18 inches apart when they reach 3 inches tall. The thinnings are edible as greens, mild and spinach-like, with more calcium than kale. By midsummer, the plants will reach 5 to 7 feet tall and begin forming dense seed heads. When the seed heads turn from green to gold and the seeds fall out easily when you rub them between your fingers, cut the heads and hang them upside down over a clean sheet in a dry, ventilated space. After 2 weeks, thresh by rubbing the heads together and winnow by pouring the seeds slowly between 2 buckets in a light breeze. The chaff blows away. The dense, shiny seeds drop straight down. One plant will produce enough seed to plant a 1/4 acre the following year. For your beans, plant after soil temperature reaches 60 degrees Fahrenheit. Bush varieties are easier for small spaces, but pole varieties produce more per square foot over a longer season. Let the pods dry completely on the vine. You will hear the seeds rattle inside when they are ready. Pick them, shell them on a rainy afternoon, and store them in glass jars in a cool, dark place. They will remain viable for 3 to 5 years. For tomatoes, let one perfect fruit from your best plant ripen fully, almost to the point of overripeness. Scoop the seeds and gel into a glass jar with a few tablespoons of water. Let it sit uncovered at room temperature for 3 days. A mold will form on top. This is fermentation, and it serves a purpose. The process breaks down the germination inhibitor that coats each seed, mimicking what would happen in nature as the fruit decomposed on the ground. After 3 days, add more water, stir, and pour off the floating pulp and hollow seeds. The good seeds sink. Rinse them in a fine strainer and spread them on a paper plate to dry. In 2 weeks, they are ready to store. They will remain viable for 4 to 6 years. Winter squash is the simplest of all. Grow it. Eat it. Save the seeds from inside. Spread them on a screen to dry for a week and store them in an envelope. Squash seeds remain viable for 6 years or more. The only caution is cross-pollination. If you grow more than one variety of the same species, within a 1/4 mile, they can cross, and the saved seed may not produce the same variety the following year. Butternut squash is Cucurbita moscata. Most other common winter squashes, including Hubbard, buttercup, and acorn, are Cucurbita maxima or Cucurbita pepo. Grow one variety of each species and they will not cross. This is the kind of knowledge that was once common at every farm kitchen table and is now treated as specialized botany. The most common mistake new seed savers make is not saving from enough plants. If you save seed from only your single best plant, you narrow the genetic diversity of your line. Over a few generations, this can lead to inbreeding depression, reduced vigor, and increased disease susceptibility. Save seed from at least 6 plants of each variety, selecting the healthiest and most productive individuals, but keeping the genetic base broad. This mirrors what your great-grandparents did instinctively. They saved from many plants. They traded with neighbors to introduce new genetics. They understood diversity as strength without ever using that terminology. Within 3 seasons of saving your own seed from these 4 crops, you will notice something remarkable. The plants will begin to perform differently than they did in the first year. They will germinate faster in your specific soil temperature. They will show improved tolerance to whatever stress is most common in your area, whether that is late frost, midsummer drought, or a particular fungal pressure. You are not imagining this. You are watching natural selection operate in real time on your own land. The seeds are adapting. They are becoming yours in a way no purchased seed can ever be. These 4 crops are not the end. They are the door. Once you understand the principle of seed sovereignty, the open-pollinated world expands enormously. Grain sorghum grows in conditions too hot and dry for corn, produces animal feed and human food, and has been cultivated in Africa for over 5,000 years. Cowpeas, also called black-eyed peas, fix atmospheric nitrogen into your soil at a rate of over 100 pounds per acre, eliminating the need for purchased nitrogen fertilizer while producing a high-protein food crop. Flint corn varieties, the same types grown by the Iroquois Confederacy, produce grain that stores for years without refrigeration and grinds into meal that tastes nothing like the bland commodity cornmeal on supermarket shelves. Perennial crops open yet another dimension. Jerusalem artichoke, native to North America, produces starchy tubers that yield over 15,000 pounds per acre without replanting because the plant returns from its own root system every spring. Egyptian walking onion produces new bulbils at the top of each stalk, which bend over under their own weight and plant themselves, literally walking across your garden over the years. These are not novelties. These are the crops that sustained civilizations before the age of patents and petrochemicals. Each one is an open-pollinated, self-renewing food source that requires no annual purchase, no corporate permission, and no chemical input. The system your great-grandparents used was not primitive. It was a complete, self-sustaining technology for converting sunlight, water, and soil biology into human nutrition. It was replaced not because it failed, but because it could not be monetized. You cannot build a $63 billion industry on a farmer who needs nothing from you. You cannot sell fertilizer to someone whose beans fix their own nitrogen. You cannot sell seed to someone who saves their own. You cannot sell pesticides to someone whose polyculture confuses and repels the pests that monoculture attracts. The entire input economy of modern agriculture depends on farmers forgetting what their ancestors knew. Every packet of open-pollinated seed you save is an act of economic independence. Every season you grow food without purchased chemicals is a season you have opted out of a system designed to extract wealth from the people who do the actual work of growing food. There is a weight to this knowledge that goes beyond gardening advice. What we are talking about is the fundamental relationship between a person and the ground beneath their feet. For most of human history, that relationship was direct. You understood your soil because your life depended on it. You saved seed because the alternative was hunger. You observed your crops with the same attention a sailor gives the weather, because the consequences of inattention were severe and immediate. Industrial agriculture severed that relationship and replaced it with a dependency. Instead of understanding your soil, you test it and buy amendments. Instead of saving seed, you order from a catalog. Instead of observing pest pressure and responding with diversity, you spray. Each substitution moves knowledge out of your hands and money out of your pocket. Each one makes you less capable and more dependent. The people who built this system did not do it out of malice. They did it because there is enormous profit in dependency and no profit in self-reliance. Understanding that distinction is not cynicism. It is clarity. The seeds are still out there. The knowledge is still alive. The soil beneath your feet is still waiting for someone who remembers how to listen to it. You have the ground. Now you have the knowing. The rest is just planting.